Breaker types. Circuit breakers are classified according to the medium that is used to interrupt the arc. The mediums are air, oil, sulfur hexafluoride, or SF6, and a vacuum. Air brake circuit breakers extinguish the arc by simply stretching it until the dielectric strength of the gap is larger than the voltage across the gap. There are various methods employed by the different types of air brake circuit breakers to increase their effectiveness. The magnetic air circuit breaker interrupts the air between two separable contacts with the aid of magnetic blowout coils. As the current-carrying contacts separate during a fault condition, the arc is drawn out horizontally and transferred to a set of arcing contacts. Simultaneously, the blowout coil provides a magnetic field to draw the arc upward into the arc chutes. Aided by the blowout coil magnetic field and thermal effects, accelerates upward into the arc chute, where it is elongated and divided into many small segments. Compressed air circuit breakers, or air blast circuit breakers, depend on a stream of compressed air directed toward the separable contacts of the breaker to interrupt the arc formed when the breaker is opened. Oil circuit breakers function by drawing the arc under oil, thereby extinguishing it. When the electric arc is drawn under oil, the arc vaporizes the oil and creates a large bubble that surrounds the arc. The gas inside the bubble is predominantly hydrogen, which impairs ionization. The decomposition of oil into gas requires energy that comes from the heat generated by the arc. Oil surrounding the bubble conducts the heat away from the arc and thus also contributes to deionization of the arc. The primary disadvantage of the oil circuit breakers is the flammability of the oil and the maintenance necessary to keep the oil in good condition. Sulfur hexafluoride, or SF6 gas, is an alternative to air as an interrupting medium. SF6 is a colorless, non-toxic gas with good thermal conductivity and density approximately 5 times that of air. SF6 is chemically inert up to temperatures of 150 degrees Celsius and will not react with metals, plastics, and other materials commonly used in the construction of high-voltage circuit breakers. The principle of operation is similar to the air blast breakers, except that the SF6 gas is not discharged into the atmosphere. A vacuum circuit breaker utilizes a vacuum to extinguish arcing when the circuit breaker is opened and to act as a dielectric to insulate the contacts after the arc is interrupted. Vacuum circuit breakers are mostly used in low and medium voltage applications. Due to the high dielectric strength of a vacuum, the interrupters and the gap between the contacts are small, and the sealed interrupting chamber of the vacuum breakers are made of porcelain. Circuit breakers requirements. The requirements for a circuit breaker are as follows. It should be a perfect conductor in the closed position. It should be a perfect insulator in the open position. It should be fast when closing. Current actually starts flowing before the contacts touch, and slow closures can damage the contacts. It should be fast when opening, but it must not extinguish the current before its zero crossing, and it must not produce overvoltages. The most important operation of a circuit breaker, from the protection aspect, is the interruption of high short-circuit currents. The amount of energy that is dissipated during breaker operation is extremely high. For example, the amount of energy dissipated per phase by a 3-cycle breaker interrupting 10 kiloamps of short-circuit current is almost equivalent to stopping 100,000 kilograms moving at a speed of 36 kilometers per hour in approximately 50 milliseconds. Breaker selection. The selection of any circuit breaker is based on its ability to perform the following basic functions: carry the required full load current without overheating, switch and isolate or disconnect the load from the source at the system voltage, and interrupt any possible abnormally high operating current or short circuit current likely to be encountered during operation. These functions all must be performed over an acceptable period of time and under the actual operating and environmental conditions. To help us in selecting the correct circuit breaker for our situation, we will need to look at the ratings for that circuit breaker. Voltage ratings. The voltage rating of the breaker specifies the maximum voltage level of the line that the breaker can be used on. Current ratings. 3 current factors must be considered. The first is ensuring the breaker can carry the system's full load current. The second is to ensure that the breaker's rated current is capable of breaking the maximum amount of faulted current. And the third is to ensure the breaker is capable of carrying the faulted current for a period of 1 second. Operating time. Two characteristics of operating time must be observed prior to selection. The first is the time the breaker takes to open a short circuit current after it is activated. The second characteristic is the time between operations. After a fault is cleared, the open breaker is usually heated significantly. Before the breaker can be closed, it must be given sufficient time to cool. Once the breaker is cool, it can be closed and operate normally. Without being given cooling time, damage may result in the event of several faults occurring in a short period of time. If the cooling time of the breaker is not specified, standard cooling time is approximately 3 minutes for breakers not intended for rapid reclosing, and 0.3 seconds for breakers intended for automatic reclosing. Temperature range. Temperature affects circuit breaker operation in that below a specific temperature, mechanism operation will not be reliable due to possible freezing of condensation inside the circuit breaker, freezing of lubricants, and or mechanical interference effects caused by changes in the physical dimensions of the components. Also, physical properties of materials may change. With extreme cold, some materials might tend toward brittleness. Under increased heat, physical or electrical strength of some materials may be reduced to marginal levels. Some materials can begin to melt, and the useful life of insulation can be seriously reduced. The application engineer selecting the circuit breaker should take each of these factors into consideration. Altitude. As the altitude of insulation increases, atmospheric pressure and air density decrease. The reduced insulation and heat transfer properties of less dense air require that circuit breakers be derated for voltage withstand and current carrying capacity. Current derating can be compensated to some degree if the temperature at the higher altitude is lower, but voltage withstand capability is essentially unaffected by lower temperatures at the higher altitude. Insulation level. There are two separate electrical conditions under which the insulation of the equipment may be required to operate: electrically exposed and non-exposed. Essentially, this means whether the insulation is mounted indoor or outdoor. Outdoor switchgears are exposed to atmospheric conditions, such as lightning, which can cause overvoltages. For a 500 kilovolt system, the rated lightning impulse withstand voltage is approximately 1500 kilovolts. The rated switching impulse voltage is approximately 1200 kilovolts. 1 minute power frequency withstand voltage for a 500 kilovolt system is approximately 600 kilovolts. Trip and close coils. The number of trip and close coils depends on whether the application is intended for single or 3-pole closing. If the application is single-pole closing, as typically used in transmission line applications, each breaker will require 2 trip and 2 close coils for each phase, 1 each for standard operation, and an additional 1 each for redundancy. A 3-phase line will therefore contain a total of 6 trip and 6 close coils. Lifespan. The maintenance standards also play an important role in breaker selection. The type of arcing contact material determines the life and the number of braking operations a circuit breaker can perform in its lifespan. Each circuit breaker, depending on the type and the materials used, will be specified with the number of breaker operations in its lifetime before it should be taken in.